hiker is missing in a national park. Thousands of acres of forest, cliffs, rivers and trails. The search team arrives at dawn. Where do they look? Random guessing wastes time. Systematic plan saves lives. This is the story of how Latin Hypercube Sampling, sensitivity analysis, and Bayesian inference work together, told through a search and rescue mission. The first instinct: send search parties to random locations. 15 teams, 15 random coordinates. But look at the map. 3 teams ended up in the same clearing while the entire eastern ridge was never visited. Gaps and clusters. Some areas searched multiple times, others completely missed. With a lost hiker, every hour matters. Random sampling is inefficient. It doesn't guarantee coverage. Latin Hypercube Sampling fixes this. Divide the park into a grid, 5 rows and 5 columns. The rule: every row gets exactly 1 search party and every column gets exactly 1 search party. No row is skipped. No column is empty. The entire park is covered systematically, with no gaps and no redundancy. The same number of search parties, but now every region of the park has been visited. This is LHS, maximum coverage with minimum resources. But not every great cell makes sense. These cliff faces are vertical. A hiker can't traverse them. This deep lake is impassable. The hiker physically cannot be in these locations. Behavioral filtering eliminates implausible regions before the search even begins. Cross out the cliffs. Cross out the lakes. The search space shrinks. Every remaining search party is now deployed to a location where the hiker could actually be. 4 factors could predict the hiker's location. Distance from the last known position. Sensitivity index 0.85, the strongest predictor. Proximity to trails 0.72, hikers follow trails even when lost. Elevation 0.15, barely matters. Vegetation type 0.08, irrelevant. Sensitivity analysis tells the search commander, focus on distance and trails. Don't waste teams checking every elevation contour or cataloguing every tree species. 2 factors drive the prediction. Focus the search. Based on all plausible scenarios from the LHS exploration, the search team draws 2 rings on the map. The inner ring, 5 kilometers from the last known position. The hiker is most likely within this circle. The outer ring, 15 kilometers. There's a small chance the hiker traveled this far. Uncertainty characterization doesn't give one answer. It gives a range, most likely here, possibly as far as there. The search commander now knows how wide to cast the net. The search plan is set. LHS explored the park systematically, no gaps. Behavioral filtering eliminated the impossible, cliffs and lakes crossed out. Sensitivity analysis focused the effort, distance and trails matter most. Uncertainty characterization defined the range, 5 kilometers likely, 15 possible. The exploration is complete. Next, the actual rescue.